Good morning everyone. Let's start with object-oriented design approach today. Object-oriented design approach we have introduced in the few lectures back. So in the object-oriented design now we will be working on system modeling part. What do you mean by system modeling? Like system modeling is the process of developing abstract model of the system. So from the name it is clear, it's just a process of making a model or a framework for the system. But why so many models? Because it is going to represent the system with different viewpoints or perspective, or call it as different angles, to understand the system in a better way. Apart from this, system modeling is again a graphical way of representing your system. If anything which is graphically represented is well understood and clear, while if you write anything just in a form of a text document, it decreases the visibility of the system or understandability of the system. So we always take the help of view diagrams wherever possible. Now for this graphical notations, what is being used is the UML language, that is Unified Modeling Language. So UML is nothing, it is a graphical way of representing the system where different set of models will be prepared based on different perspectives, right? System modeling helps the analyst to understand the functionality of a system, right? It is clear. We know that we make the diagram in this RS also. So who works in the requirement analysis? Who do the task? It is being done by the analyst. So here we are talking about that during the requirement analysis, this analyst has to understand the functionality of the system. So it is well understood with the help of the diagrams, as well as he has to communicate with the customers that this is what he has identified and whether the customer is satisfied with that or not. So they both communicate, the customer as well as the developer, or you can call it as an analyst, and they conclude at one particular point, okay fine, this is what a system needs to be developed. So in the previous slide you must have seen few topics, right? So this system modeling basically has different categories of model that needs to be prepared. That is context model, where we prepare a context diagram, interaction models where use case and sequence diagram is prepared, structural model where a class diagram is prepared, and a behavioral model where we prepare state transition diagram. Apart from that, we have process diagram, activity diagram, so many diagrams are there. But as far the syllabus is concerned, we'll be discussing this. So system modeling, okay fine, we will be preparing the models here. Now what for these models are used? These models can be used in two different scenarios. First scenario is if you are going to prepare a model for an existing system. Say you are supposed to automate a system where we have already an existing system is in place, which is manual in nature. You just have to automate it. So in order to understand that existing system, the diagrams or the models helps us, right? So it is stated here, models of the existing system are used during the requirement engineering. They help clarify what the existing system does and can be used as a basis for discussing its strength and weakness. These then led to requirements for the new system. So ultimately you have to understand the existing system, identify its strength and weakness, and then you can identify the modified requirements for the new system that requires to be developed. So this is one of the cases. One second case is when we are supposed to develop a new system from scratch whose existing system is not present, right? So in that case, again, the models are prepared during the requirement engineering to help explain the proposed requirement to other system stakeholders. That means what your system is going to do, right? You'll be identifying all those requirements. So you have to convey these requirements to the stakeholders, whosoever is concerned with that system. Engineers use these models to discuss design proposals and to document the system for implementation. Simply, right? So summarizing, one possible way it is used to understand the existing system, and second, it helps us to identify a requirement for the new system. Now what are system perspectives or the viewpoints? There are basically four system perspectives: external perspective, interaction perspective, structural perspective, and behavioral perspective. So what do you mean by these perspectives? An external perspective where you model the context or the environment of the system. So external perspective simply means like you're supposed to develop a system, right? So you will tell in the external perspective कि your system that is under development, how it is going to interact with the external environment. For example, if you're making a software that is library automation system for graphic era, so the system which is under development is your library automation system. But yes, this library automation system requires the students data, employee data. So do he need to prepare the database again? No. We can fetch this information from the admissions or the student management system where already the information of students are already present. So why to make it again? So this is what it says. You have to definitely use some external system where the data is already present. So we just get the data from those environment, external environment. So external perspective is that where you model the context. Context means the main title or the topic or the environment of the system is represented. We make actually the context diagram here, right? So we'll be discussing in the next slide. And interaction perspective is what? Interaction perspective represents the interaction between a system and its environment or between the components of the system. What does it mean? Here also we have represented the environment. Here also we are representing the system and the environment. So what is the difference? In the external perspective, we only show which all external system is going to participate with your system. While internal interaction perspective shows how that system is going to interact with those environment or the external system. So the process of interaction is represented here. Or you can say it also represents the components, interaction between the components of the system. So there might be multiple classes in a system who are going to interact with each other in order to give a desired outcome. So we'll be representing both the type of interactions. The first is between the system and its environment. It is basically represented with a use case diagram. While the second category, the interaction between the components of a system, this is represented by a sequence diagram. The third perspective. The third perspective is a structural perspective. As the name suggests, structural perspective is it shows the structure of a system, or you can say organization of a system, right? That is processed by the system. So how a system is being organized, maybe in a hierarchy, right? That is being represented here. The diagram which is prepared here is known as a class diagram. The fourth category, a behavioral perspective. As the name suggests, behavioral perspective means is we have to model the runtime behavior of the system, that is dynamic behavior of the system, and how it is going to respond to different events when certain inputs are given at the runtime. So how the system is going to behave, what are the outputs that are being achieved, that is represented using this behavioral perspective. So basically if we prepare a state transition diagram here. So four perspective: external perspective, interaction perspective, structural perspective, and behavioral perspective. In the external perspective, we prepare context diagram and a process diagram. In the interaction perspective, we prepare use case diagram and a sequence diagram. In structural perspective, we prepare class diagrams, and in the behavioral perspective, we prepare activity diagram and state transition diagram. So this is what a brief summary of all the models that we will be doing, which are based on different perspectives. So what are UML diagram types? So these are the few listed here: activity diagram, use case diagram, sequence diagram, class diagram, and state diagram. So roughly what are these? Activity diagram shows the activities involved in a process or in data processing. So from the name it is clear, it represents the activities only. Use case diagram shows the interaction between a system and its environment. We have seen in the previous slide. Sequence diagram which shows interaction between actors and the system and between the system components. Okay, fine. Class diagram which shows the object classes in the system and the association between these classes. Right? We'll be doing it later to understand it in a better way. State diagrams which shows how the system reacts to internal and external events. So we have done a case study. This was the reason the case study was taken up previously, because now we'll be making all these diagrams for those case studies to understand the system. Right? So for these we will be using certain graphical models. So what is the use exactly? Why graphical models? Graphical models act as a means of facilitating discussion about an existing or a proposed system. This is what we have seen. Two scenarios were there. Either for the existing system we'll be using it to understand it, or for the requirements of the proposed system can be better understood. Second, a way of documenting an existing system. Okay, fine. Third, as a detailed system description that can be used to generate a system implementation. So we know that these models act as an intermediate step between the requirements and the coding or the implementation part. So these diagrams will be finally converted or implemented in any of the language. So it provides us with a detailed system description. Now, what is a context model? Context models are used to illustrate the operational context of a system. They show what lie outside the system boundaries. So context will be represented. They have a specific boundary. Specific boundary here means is the entire task will be carried out within the boundary itself. While outside the boundary, some other system will be there and their functionality will be different. If another, like you can have more than one system boundary. Let's take an example here. This is for mental health care patient management system. The case study we have already discussed. So if I say this is your major context, the system that is under development, mental health care patient management system. Now for this we are preparing a context diagram. So context diagram says we have to model the external environment which are going to interact with the system. Right? We don't have to develop it again. Say this mental health care patient management system was a government campaign, if you remember, that is being carried out at different clinics or the local, you can say the outlets, right? So you don't have to develop the entire system for this. Entire hospital system is already present in that region. We will be using the services of those hospitals and will be treating our mentally sick people using it. So this is what the major context is. And what are the external systems that are going to interact? First of all, a patient record system, which is already in place in the hospitals. You just have to simply store the information. Either you can store the information here or you can retrieve the information of any patient from here. So we'll be interacting with the patient record system to and fro. So likewise, another system that is going to be used here is an admission system. See, you want to admit that patient to the hospital. Maybe he is severely ill, mentally sick, and he could be fatal to himself. So you need an admission system in place. So system is represented, written in this, you can say the braces, and the name of the system is written here. Right? The third system that will be used is a prescription system. Right? That is also present in the hospitals, a prescription system. We are not talking about the manual system. It's an automated system, entire system, right? So there will be certain procedure of making the prescriptions where the patient's information would be there, his illness will be written here. Like manually, a doctor prepares a prescription and the treatment given will be prescribed here. So that will be utilized here. Then an appointment system. Appointment system is like you have to seek an appointment. So you either go to the hospital and take the appointment, or telephonically you can take it, or through emails, whatever means it is. An appointment system is already present. So that will be utilized here for the system also. Then these are two distinct systems that are being used here. The first one is a healthcare statistics system. Healthcare statistics system is, since we know that it is a campaign and you have to treat all the mentally sick people in that region, so you have to prepare or maintain the complete stats for that. Okay, how many mentally sick people were there, how many are undergoing treatment, how many are recovered, and like whatever is the case, right? So entire statistics needs to be maintained by each and every clinic or the hospital present or associated with this system. The last one, that is management reporting system. You have to prepare a management report here where which indicates, say, how much was the drug prescribed, what was the cost involved, how many patients were there, how many are treated, and all that. So a monthly management report needs to be prepared for the system. So this is what a context model is. It is not showing any process. It is only representing the major context. These all are the context. It is not going to represent the implementation or the processing part. Only the names of the system which will be interacting, right? So our system interacting with the external system. So we were talking about, so it illustrates the operational context. Okay, fine. Social and organizational concerns may affect the decision on where to position the system boundaries, right? Architectural models show the system and its relationship with other systems. Okay, fine. This is an architectural way of representing how the system are going to interact with each other. What are system boundaries? System boundaries are established to define what is inside and what is outside. So what is a system boundary? This is the boundary. So what is inside? The functionality of the system. What is outside? The functionalities of this. What is inside this? Functionality of admission system, right? So in and out, all we have specified the boundaries. That means in this boundary, the functionality of the specified system is being carried out here. The position of the system boundary has a profound effect on the system requirement. Defining a system boundary is a political judgment. What does it mean? There may be pressures to develop system boundaries that increase or decrease the influence or workload of different parts of an organization. Say, let's assume a good example here. Say if a class is held somewhere nearer to the staff room, so it's always a point in a mind. Okay, if our class is being held next to the staff room, anytime anybody could come and keep a check on the class. Why? If you have a class which is being, the venue is somewhere on the top floor, so there is a least possibility that a person would come frequently, right? So this is what a political judgment could be. So influence could be there. So this was your context diagram. Another one, the process perspective. So I said in the context model we prepared two diagrams, that is the context diagram and another one is the process diagram. So process diagram is what? It represents the process. Simply let's take an example. A process of involuntary detention of a patient in mental health care patient management system. What does it mean? Say we have a system to treat the mentally sick people. Now let's assume a scenario. The person is severely mentally sick and he can be dangerous to himself or the people around him. So in that case, he is not aware about his illness because he is mentally sick, right? So we have to involuntary, that is against his will, we have to put him in a secure place. So that entire process of keeping that person who is mentally sick, who could be dangerous, against his will in a secure place. So understood the process? The process of involuntary keeping a person in a secure place. So what all things will be involved here? That is represented with a process model. Detention, like involuntary against his will, we are going to keep him in a secure place. So process diagram. First of all, the notations. A solid bubble represents a start. A solid bubble encircled with a circle represents a stop. These oval represents the process symbol. This rectangular bar represents the parallel activities, right? So parallel activity starts here. parallel activities ends here, right? So parallelism is represented with this rectangular bar. Now, if there is any condition, that is represented with this rhombus, right? So, the conditions are written in this square bracket. Say, the person is not dangerous, will be executing this. If the person is dangerous, will be executing this particular process. So, the conditions are written here in the square bracket and it is being represented with the rhombus. Now, apart from this, we are representing an entity symbol here, that is a rectangle. That means this system is going to interact here or it is being utilized here. So, the system, admission system here will take part, this system will take part here, right? So, this again a rectangular bar, that is parallel activities, ending it here and then stop. So, the notations are simple: a solid bubble encircled with a circle, rectangular bars, arrows, condition, you can say if you have an alternative path, and the condition written in the square bracket. So these are the notations used in a process model. So let's start with the process. See, the first process will be confirm detention decision. Once you're confirmed that you have to detain that person, so what we will do next? See, so you're confirmed with this. Now there are two set of activities. First of all, inform patient of rights. You cannot put any person in a secure place or in a police station or in a mental hospital uh, because that is being governed by laws, right? There are certain laws that are working for the rights of the human beings. So very first thing is inform the patient about the rights, that this is the law and if you're dangerous we'll be putting you in the secure place, right? And second, this detention decision has to be recorded in the system. So in which system? Our system which is under development, that is mental health care patient management system. So two activities are there. So a rectangular bar, we will be informing the patients and we will be recording our decision in the system. So this is what the recording the records will be updated here. These two activities ends here, right? After this, you have informed the patient, you have recorded it. Now, there is a condition, right? Now, two possibilities are there. Either the person is dangerous or the person is not dangerous. Both the things are possible. So, if a person is not dangerous, admit him to a normal hospital because he needs treatment. He is mentally sick. So, you have to admit him to the hospital. You cannot leave him roaming around here and there because there could be like he is not too serious but yes needs some medication for that. So while you're going to admit him to an hospital, the admission system comes into place. So we will be utilizing this admission system to hospitalize this person, right? So this is one particular, if not dangerous, admit him to a normal hospital, right? While if the person is dangerous, so you need to find a secure place. You cannot admit him to the normal hospital because he is dangerous. He can harm him or the other patients who are around or the staff or the doctors, right? So we'll be finding a secure place. Now again a possibility, it can be represented with the rhombus also, or we can write it this way, just an arrow and the condition mentioned out here. So if you're finding a secure place and it is available, right? So if the, like you can say, hospital bed is available, transfer him to the secure hospital simply. Not a normal hospital. Secure hospital means which are specifically meant for mentally sick people. Well, if it is not available, that means in the secure hospital no space was available. So in that case, since he is dangerous, we have to transfer him to the police station, right? This is what the reason we were supposed to inform the patient about the rights, because we are going to put him behind the bars. It is against the law, so it has to be informed. Now, once you have carried out these three activities, either admit him to the normal hospital or to a secure hospital or to the police stations, then again these ends here and parallel activity starts. What is our parallel activity? The first one is inform the social care units. Why to inform these social care units? Social care unit means NGOs who are working for the benefit of certain, you can say, categories of people, or to some locality or some other things, right? So you have to inform them. If you're not going to inform them, say you have put him in a hospital, or like secure hospital or a police station, these NGOs will come and again they will file an FIR against you, how you have done this. So better is you inform these social care units or the NGOs. Second is inform next of kin. Next of kin means relatives. So you have to inform the relatives that this is the person who was like needs admission in the hospital and you have admitted him. So inform his relatives who takes care of that patient. And the lastly, once you updated, like inform the next of kin, update this decision in your system. So we have to update the register in the system which is under development, that is mental health care patient management system. So simple, we carry out these three activities, all the three activities end here and the process ends here. So this is your process model. So simply what all activities are there, simply with the help of these notations and a proper sequence has to be maintained till the end, the process is completed. So this was all about your process model of involuntary detention of a patient in mental health care patient management system. So for today we'll be ending it here. In the next lecture we'll be starting with another diagrams. Thank you.